Please pause the video and take a moment to read this important safety message.
All right, hopefully another fun video here at Blue Glow Electronics today. Today's topic is death capacitors in vintage gear, and we're going to do the traditional approach I've been using lately. A little bit of classroom education, then we're going to go hit the bench and actually deal with one of these in a real unit. All right, stick with me and I'll try to get everyone up to speed on at least what a death capacitor is here. It was historically, a death capacitor was never designed to be a death capacitor, and it was never really called a death capacitor to begin with. What it was a basically a filter capacitor. It was a capacitor being used between one leg of the power cord and the chassis of vintage electronics to provide an AC ground to help suppress RFI and other externally induced noise, typically to your power cord. So in other words, your power cord may be stretched out across the stage or across your room, and it can act like a great big antenna, picking up various RF signals or maybe noise induced by a microwave oven or a motor, a fan or something in the vicinity. And it would carry that signal into your amplifier and then get amplified as part of your amplifier circuit, thus coming out the speaker, making noises you don't like. So theoretically, this capacitor was supposed to connect between the neutral line of your power cord and the chassis itself. And we'll talk a little bit more in a minute about how it provides this filtering. But the problem lies in that with older gear with two-prong cords, there was typically no indicator to determine when the power cord was plugged in properly or not. So you could plug it in one way, and all of a sudden you've got the neutral line connected through this capacitor to ground. You plug the cord in the other way, and you actually have the hot line connected through this capacitor to ground. So if theoretically you've got your power cord plugged in properly and the neutral line just happens to hit the right blade in your wall outlet there, not that there's anything to tell you which way to plug it in properly, and you plug it in and you happen to get it right, things are likely okay for you, okay? If you happen to get it wrong and now you're feeding the hot wire over to this capacitor, what you're doing is you're sending a current, AC current, through that death capacitor, and we'll talk more about that in a minute, to the chassis of your amplifier at that point. Well, if this happens to be an amplifier you're using for musical purposes, such as a guitar amplifier, or maybe you're plugging in a microphone into this for singing purposes, all of a sudden you're carrying through the ground in your amplifier out through your guitar cord or microphone cord to the guitar strings, because typically that's grounded to the bridge of a guitar, or in the case of a microphone, to the microphone case itself. You're feeding this small AC current through there, and the individual touching this device may actually feel it. Okay, if you can hang with me and understand this next little section, it is by far the most technical that I will probably go into in this video series, and probably the most difficult to understand. But if you can get your head around it, then you'll actually understand these death capacitors and what they do and why they're so dangerous. So hang with me on this. Okay, you remember when we were doing the coupling capacitor video, we talked about this concept of a high-pass filter. In other words, we wanted to let high-frequency signal flow through our amplifier from one stage to the other, but we wanted to send very low frequencies like DC off to ground and kind of not let those flow from one stage to the other. Well, we're doing a very similar thing here with this death capacitor, except it's kind of the opposite. What we're creating is a concept called a low-pass filter. In other words, we want to pick a frequency, F sub C here, of this little filter capacitor setup that allows low frequency signals like 60 hertz, or 50 hertz if you're in Europe, to flow on through from your wall outlet. This is my bad attempt at drawing a two-prong wall outlet. You're wanting to allow that 60 hertz AC signal to flow on through into your power supply and ultimately feed power to the rest of your amplifier. And what you're wanting to do is take frequencies that may get induced on these lines such as we talked earlier, maybe some noise from your microwave, maybe some RF. Have you ever heard your phone kind of sync and it induces a signal into your audio setup? Maybe noise from a local fan or a welder, things of that nature. Basically noise and harmonics that may get induced onto this AC power line somewhere. We're wanting to take those things higher than 60 hertz, and we're wanting to send them off through this capacitor here to ground. Okay, so we have to pick a value of the capacitor that will do that for us, and the formula for that is 1 over 2 pi RC. And since we know we're dealing with 60 hertz, you can kind of do the math and ultimately come up with that, okay? But that's not relevant to, we're not designing power supplies and designing amplifiers today. All right, so the main concept you want to grasp out of this, okay? We are using a concept called a low-pass filter to allow the pure AC signal, 50 or 60 hertz, to feed straight on through into your power supply and power your unit, whatever it is, amplifier, TV, computer, whatever. And you're wanting to take any high frequency noise, hiss, RF, hash, whatever it is that gets on your line somewhere prior to your unit here. And we're going to use a low pass filter to send that high frequency stuff off to the chassis ground and never on into your power supply and the rest of your amplifier, thus getting rid of the noise that could be generated by this and not having this low pass filter in place. So you may ask the question then, well, if I happen to plug my cord in wrong and I have the hot line feeding to the death capacitor, why does not all the hot line feed through that capacitor to the chassis and end up shocking me? Well, here is why, and you hold tight and grasp this one. It is because this capacitor has something called reactance, okay? Capacitors and inductors are what they call reactive devices. In other words, they play different roles at different frequencies, okay? And what I'm saying here is the current is limited by the resistance, in other words, reactance, of the death capacitor. But there's still enough there to give you a tingle or startle you if you're not experiencing it, okay? So there is a formula for reactance, and it's not much different than the formula for the cutoff frequency of a low-pass filter or high-pass filter. The reactance formula is 1 over 2 pi frequency times capacitance. So let's do the math on this. 1 over 2 times pi. Pi, as always, we're going to just use 3.14. In this case, we're going to use 60 hertz. So 1 over 2 times 3.14 times 60 hertz times, in this case, we're just going to say a 0.05 microfarad capacitor, because that's a pretty common value you see for death capacitors. If you do the math on that, it comes out to be 53,000 ohms of reactance, which is the kind of the equivalent of resistance in a reactive world. In other words, 53,000 ohms. And then if we do some math that says 120 volts divided by 53 kiloohms, and just using plain Ohm's law here, right? I is equal to V over R. You end up with about 2.3 milliamps of AC current flowing to the chassis at 120 volts. In other words, it's enough to let you know it's there, but probably not enough to kill you. I'll give you an example. If you've ever taken a 9-volt battery and stuck it on your tongue, you get just a little bit of a tingle, not enough to kill you or hurt you. The reason is there's not enough current there to kill you. And so if you plug this unit in backwards and you actually had the hot line here feeding through this capacitor, you would have about 2.3 milliamps of 120 volt AC flowing through that capacitor to the chassis, which then might make it out to your guitar strings, might make it out to the case of your microphone. Ultimately, you would feel it. It would tingle, much like licking the 9-volt battery, but it's not enough there to kill you, okay? So if you're going to say then, Mark, well, this capacitor at 60 hertz is acting somewhat like a resistor and letting some of this current flow through to the chassis, 2.3 milliamps or so, and you're saying that's enough to tingle but not yet kill you, Well, then what's the big deal? Why not put a death capacitor or leave a death capacitor in place? Well, here's the issue, okay? The real issue presents itself when the death cap, which might be 50 or 60 years old now, when it dies for whatever reason. Keep in mind, these are old capacitors. They're starting to dry out. They're starting to, maybe they've drawn moisture over time. Whatever might cause it to fail. If it fails, and when it fails, it shorts, okay? You all of a sudden don't have anything to limit the current going to your guitar, your mic, or the chassis of this unit. It can kill you. So that 53 kiloohms of resistance, if this capacitor shorts, if you did the math here again and took the capacitance value to 0, basically what you end up with is a dead short between the AC wall outlet on the hot side and your guitar strings and or your microphone. It can kill you. So the problem is when these units fail, these 50, 60-year-old capacitors, it creates a really ugly scenario for you. And thus, over time, these things have earned the name the death capacitor, okay? You see a couple different pictures here. These things get situated in a lot of different ways. Sometimes they're connected over here off of one lug of your power switch, then they just tie to ground. Other times they're coming off of the side of your fuse here and going to ground. Sometimes they're coming off of the leg of maybe a secondary power outlet in the back of your unit. This unit picture I took right here is actually of the ICO HF85 I've been working on, and you can see it kind of ties between ground and one leg here of an external power plug that you could use for auxiliary purposes. So yes, these things have earned the name death capacitor for a good reason. All right, so I pulled together some various schematics from various old amplifiers. Some of these are old Fender guitar amplifiers. Some of these were audio amplifiers, whatnot. Anyway, you can see here you got your 2-prong power cord feeding in. Sometimes they used to switch a different leg than they fused, which is not a good practice, but they did it anyway. Anyway, you can see here a 0.05 at 600 volts capacitor here feeding off of one leg of this to ground here, and that would be the infamous death capacitor. Similar scenario here, fused on one side, switched on the other, death capacitor 0.05 to ground. You can see here, you kind of got your wall outlet. You got a few power jacks in between here. You've got a switch here on one side. I don't see a fuse anywhere in this one. And you got a 0.03 microfarad feeding off to ground. Here is your, let's call it low pass filter to filter out the noise. However, it has earned the name death capacitor. And finally, this is one that you see in a lot of guitar amplifiers. What they'll do here is they'll kind of feed both sides here with a switch. And then they'll let you be able to toggle the switch between one leg or the other to the death capacitor and ground. In other words, if you've got your amp plugged in the wrong way and you hear a little bit of hum, you can flip this switch and not have to plug your outlet in the other way. It kind of just lets you pick the lowest amount of noise for the rest of your amplifier here. All right, we're going to talk about 3 approaches on how to deal with the death capacitor, okay? And I made a note here in the blue box that these 3 are not all inclusive or exhaustive, and variations between these 3 exist as well. So I'm just giving you some high-level gist here. First and foremost, you could just simply remove the death capacitor. Come over here, snip it off, pull it out of the way, get rid of it. The pros, you remove any chance then of shock or injury, right? Because even if this capacitor shorts, if it's not in your circuit, it doesn't cause any harm. The cons, it can leave your gear with a bit of hum or hiss, as you have now lost your RFI, radio frequency interference, or AC noise filter to ground. So in other words, you would kind of be getting rid of the safety factor, the risk factor here, but doesn't necessarily get rid of your any kind of noise you might have coming in over your line into your device. So while it's a valid direction, you don't often see this one used a lot. Oh yeah, by the way, I thought I'd bring this up, and I was just out doing some research on death capacitors just to make sure I was providing all you guys all the right info and I wasn't missing anything. And the Rob Robinette website was a great source of a lot of knowledge around guitar amplifiers and whatnot. They mentioned that there is an infamous video out here, the Uncle Doug Death Cap video, and I have not personally watched this video, although I have watched some of Uncle Doug's stuff. But he basically says that Uncle Doug comes to the wrong conclusion because he failed to reverse the plug, blah, blah, blah. And he basically said if he would have, he would have realized that his conclusion. So there's some warning out here that this video is wrong. I have not watched it. I just thought I would point that out, though, since it is a popular video on this topic. All right, and then approach number 2, probably the one you see done the most. Very common with guitar or musical type amplifiers. And we'll talk a little bit more in a minute here why maybe it's not the best thing for hi-fi gear. But the first thing you do is remove the death capacitor and then replace the 2-prong cord with a modern 3-prong cord and ground the chassis to ground lug on the 3-prong cord. So pros of this, very safe approach, kind of brings you up to modern specs. The cons, on some old gear, especially hi-fi, you would be grounding the chassis to earth ground, which is also shared with the signal ground in the amplifier, and especially when you're connecting multiple pieces of equipment together, maybe a preamp, a phono amplifier, an amplifier, whatnot, you can end up with ground loops and hum, and we'll talk more about that in a minute. But typical the way the things were, you can see here in the old days, kind of your black wire, which is your hot, and your white wire, which is neutral. These things would feed in and they might fuse the neutral, they might switch the hot, lots of different scenarios you would see. And then you could see here you got this death capacitor, a 0.47 here in between on a switch. Well, the new way you would do it, you would bring the black wire in the hot, you would fuse the hot, then you would switch the hot, then you would go to your power transformer, your white or neutral, you would bring it in, feed the other side of the transformer, and then you would take your green wire and you would connect it directly, as you see here in this picture, to the chassis. Try not to connect one of these to the transformer bolt that holds your transformer down. Find a good clean place on your chassis and connect it. Typically you want this green wire to be a little longer than the white and black wires. In case the cord gets pulled out, you want this green wire to be the one that breaks last. And you may say, well, Mark, why don't you go back and just use this approach in your hi-fi gear? Seems to be very safe, and I see a lot of people do this with hi-fi gear. Well, here's a post I'm reading from Dave Lipsky, and if you don't know who he is, he's infamous in the hi-fi world. Dave, here's what he says. He says, the very best approach is to use a polarized 2-wire plug, or as a temporary measure, a 3-wire plug with the ground wire taped off. The hot lead should go to the fuse first, and then the power switch, and then to one lead of the power transformer. The neutral lead should go to the other primary lead of the transformer, and then at that same point, connect a bypass cap from the chassis to ground. In other words, use a Y-rated capacitor there. Some will cry, what if the AC socket is wired wrong? Or what if? If these things concern you, then buy one of these little plug-in test indicators down below to make sure the proposed socket, in fact, is wired correctly. But do not use a green wire ground system with vintage equipment. They were not designed with separate chassis and circuit ground systems like modern equipment is. So using a green wire ground with vintage equipment is a recipe for bad ground loop problems when the equipment is used with other pieces of gear with green ground wires like cable and or satellite equipment, so on and so forth. So it's kind of one of those it depends scenarios, and if you're dealing with vintage hi-fi like an old Fisher unit, an ICO, Dynaco, or whatever, you are completely safe to go down this path. You may go this path and be completely fine and have no noise issues whatsoever. And then again, you may plug in a modern preamp that has a green chassis ground to it like this, and your amplifier be wired up this same way, and you may have issues, ground loop issues. So just take some wisdom here from Dave. He's a long timer in the community and a very wise soul. So and this was part of an AK thread, a very long thread on this topic that I was reading up on. So any rate, you've got your three approaches. I would recommend with vintage hi-fi gear, switch over to a polarized two-prong cord and put you a Y-rated safety cap. In my case, I use X1 Y2 capacitors in place. If you don't like that approach, want to use this approach, feel free. You just know you may end up with some ground loop issues at some point. Less likely to have that issue in a guitar amp because you're probably not plugging other devices in that are grounded. The other devices you're plugging in are your guitar, your microphone, which typically don't have their own power sources to them. So you're much safer here in a guitar scenario using this path. And this one, you might could try it, but it's probably not a recommended path because you're likely going to have some RFI AC noise hum here as a result. All right, hope you learned something today in the classroom part. Let's jump over to the bench and actually do approach number 3 on this ICO HF85. All right, back to the HF85 we've been using for examples in some of these videos. Let's zoom in here. First and foremost, we've got our power cord here. If you'll notice, it is a non-polarized. In other words, both of the spades here are the exact same size. Comes in through a little hole here in the back of the unit. A knot gets tied in it as a strain relief. And then ultimately you come over here and feed one side and the other here of this. They're using an outlet here for spare equipment as kind of a tie-off point. Then you can see they come off of one side of this and they come over. Let me zoom out so you can see that. All right. They come off of one side of this here and they twist a pair of wires and they come over, and it basically comes down to the front right here to the on-off power switch. And then they feed back out of it on the other side here. They come over and tie off on this lug at that point, and then they basically go from there, from the death cap, as you can see here, down to a ground lug right here. So we're going to replace and rework this a little bit. They want to, basically here what they're doing is they're switching one side on this and really not even fusing the other side. So we're going to figure out how we want to handle that. All right, so a couple things wrong here. You know, one, I don't like this cord coming through without a grommet on the back here. It's just kind of coming through the metal. Over time, you could potentially wear through your power cord, but it's kind of the way they did these things back then. Two, there is no fuse whatsoever in line anywhere here. There's no fuse in this unit whatsoever. We go straight over here to the power switch. Nowhere in this unit on the top, bottom, anywhere is there a fuse or fuse holder. So I just believe we need to put one in just for safety. So I think we can kind of come right along in here and mount a surface mount fuse holder like this and kind of break the lines feeding to this power switch here and put the fuse in line. So we're going to come in through the power cord. I'm going to try to put a grommet on there, fuse it first, then go to the power switch, come back over here, and then we can deal with this death capacitor and how to feed the rest of the amplifier. Okay, a few modifications I made to the preamp here. One, I drilled a hole in this side right here where we're going to mount right here an inline fuse on the other side and can mount that. The other thing I did was I really wanted to put in a power cord with a rubber grommet so the power cord's not, you know, a strain relief grommet. So I've used a kind of a hole tool here, a stepper bit, to actually open this hole large enough not to just accept the cord, but now to also accept a rubber grommet. And we've got a little Heiko here, rubber grommet pinching tool that I'll use. If you don't have one of these, it's okay. These just do a really good job of holding the unit kind of at an angle and letting you squeeze the strain relief plug while you push it down in. If not, you can get by with a pair of regular pliers. Similarly, I used the stepper bit to drill this out. If you don't have one of these, you could get by with a a regular drill bit, but those were the two modifications I've made at this point. Okay, we've got the unit done now. If you'll notice here on the back, nice little strain relief grommet in place, got our cord coming in. If you'll notice here, we trace the white wire here, which actually, if you'll notice on the other side, the white wire here ends up going to the large spade, which is the neutral wire. So what I'm doing basically is I'm coming in here on this, I'm feeding the neutral wire to one side of this lug here. If you'll notice, I'm feeding over then using a little bit of Teflon wire coating here on this Y cap. The other side of this Y cap is tied off to a chassis ground point right here. The hot wire feeds over here to this other tab. It then feeds from that tab via this little gray wire right here over into one side of the fuse. Comes out the other side of the fuse, feeds over, comes down into here, into the back of the power switch right here, comes out the other side of the power switch then, feeds over here, goes into this point, feeds from there down to the power transformer on one side here. The other side of the power transformer feeds off of the neutral side here. So we are all wired up at this point, and we've got our safety cap in place. This unit is good and ready to go, and in a much safer place now that it actually has a fuse in line with it. So, all right, hope you learned something, learned how to put a safety cap in place, how to swap out a non-polarized for a polarized two-prong plug, and this unit is good to go. Thanks for watching, everybody.